Hello, boys and girls. This is Mr. Sir. Welcome back for another lesson of biology. Today we are going through lesson 17 on the sex linkage and the classwork 26.2. Before you start watching, remember to subscribe and like my channel and share the video to your classmates. Let's start. Please take out your classwork 26.2. Let's do it together to strengthen your understanding. Let's take a look at question 1. Queen Victoria of England was a carrier of haemophilia. That means she has only one allele of haemophilia in her body, but she looks normal. And this type of haemophilia, 血友病, was caused by a recessive allele on the X chromosome. So we should know that this is X-linked. And her husband, Prince Albert, was unaffected. That means her husband is also normal. So before we start doing the question, we have to let the allele first. Let the capital letter H be the allele of normal blood clotting ability, while we let the small letter h be the allele for hemophilia because it's a recessive allele. Therefore, we use small letter h. And then let's write down the phenotype of parents. So we know that for the male, the Prince Albert, he is a normal male, while for the female, Queen Victoria, she is also a normal female but a carrier. One of the X chromosome contains the hemophilia allele. And then let's write down the genotype one by one. For the genotype of Prince Albert, the normal male, he has one X chromosome and one Y chromosome. And then on top of the X chromosome, he is going to have one capital letter H, a normal allele for normal blood clotting factor. But for Queen Victoria, she has both X chromosome. And then on one of the X chromosomes, she carries the normal blood clotting ability, and the other X chromosome contains a recessive allele of hemophilia. And we are now going to draw out the types of gamete formed by Prince Albert and Victoria. Alright, so let's draw it out together. Alright, so for both Albert and Victoria, they give two types of gametes. And then for the F1, after random fertilization, you are going to have four types of phenotype of offspring coming out. Let's draw out one by one. The first type, you are going to have a female, which is normal. Normal female. And then another type after fertilization would be also a normal female, but she has a hemophilia allele. Therefore, she is not only normal, but she is also a carrier. Normal carrier female. And then another type of offspring coming out after fertilization would be, this is going to be a male, and this male is a normal male with normal blood clotting ability. The last type of offspring coming out after fertilization would be a male, but this time this male has a hemophilia allele on the X chromosome. Therefore, he is a hemophilia male. And this is the phenotype. 4 types of offspring. Question 2. Explain why hemophilia Hu is more common in males than female. In order to get all the 3 marks in these questions, you have to tell me where do you find the hemophilia allele and how many hemophilia allele and X chromosome does a male and a female has. Let's start with point number 1. This is because where do you find the hemophilia allele? You can find it on the X chromosome. Hemophilia allele or hemophilia is caused by a recessive allele on X chromosome. So this is the first thing you know. And then let's write about the case in female. For female, how many X chromosomes do they have? Females have 2 X chromosomes. And therefore, if a female will have hemophilia, she must have 2 recessive alleles on both of the X chromosomes. A female will have hemophilia only if she has recessive allele on both X chromosomes. So remember the word both X chromosomes is very important. And then what about the case of a man? For the males have only 1 X chromosome. Therefore, a male will have hemophilia even if he has only 1 recessive allele. So you get all 3 marks in part 1, part 2, describe about the case for female, and part 3, describe about the case of male. Question 3. Where did the mutation mentioned in the article occur? Why would Queen Victoria suddenly have such a mutation in her body, having a hemophilia recessive allele on her X chromosome? This is because the mutation probably occurs on Queen Victoria's parents and also in the cells such as the gametes or gametes producing cells of the parents of Queen Victoria's, and that's why it carries from the parents to Victoria, giving Victoria such a recessive allele on the X chromosome. Let's write down the answers. The mutation might have occurred in the gamete or gamete producing cells such as the ovary or testes of Queen Victoria's parents. It is the parents of Victoria who have the mutation, and only the mutation from the gametes and gamete producing cells can travel and pass from the parents to the next generation, therefore to Queen Victoria. Only the mutation in the above cells can be passed on to the next generation, giving Victoria such a new allele, the recessive hemophilia allele on the X chromosome. And you have together 2 marks. First mark, second mark. That's it for the lesson of sex determination, sex linkage, and also the classwork 26.2. I will see you in the next video. Bye bye.